Today we are going to study application of determinants and matrices. In the introduction of matrices and determinants, I have already mentioned about this application of determinants and matrices in mathematics, that is in the solution of system of linear equations, that is how to solve the system of linear equations using determinants and matrices. Okay, so here in this chapter we will study. Okay, now see, before solving the equation, system of linear equations, see, we have to check whether the system of equations is consistent or inconsistent. See, a system of equations is said to be consistent if it has one or more solutions. Okay, that is, if a system of linear equations has one or more solutions, then we say given system of linear equations is consistent. And if it has no solution, then system of linear equations is said to be inconsistent. So here, these all things we have already studied in 10th standard, but here we will study, now we are going to study, that is how to solve the linear equations using determinants and matrix. Okay, so let us take some example. X plus y is equal to 7. X minus y is equal to 1. Okay, so here let's solve this equation. Let's solve it. Add these two equations. X is equal to 4. If x is equal to 4, y is equal to 3, right? Y is equal to 3. Okay, see here, these linear equations have two solutions, right? That is 4 and 3. So this system of linear equations has two solutions. So we say this system of linear equations is consistent. Okay, if system of linear equations has one or more solutions, then it is said to be consistent. If it has no solution, then it is said to be inconsistent. So before solving the linear equations, you have to check whether the given system of linear equations is consistent or inconsistent. Okay, another example. 2x plus 3y is equal to 5. 4x plus 6y is equal to 9. See here, see, when we multiply these 2 by this equation, we will get the same thing, right? So that is, see, first equation will be 4x plus 6y is equal to 10, right? See, this type of linear, this we know that, right? In 10th standard we already studied these all things. So here these type of linear equations have no solution. Okay, see, this system of linear equations has no solution. Therefore we say this system of linear equations is inconsistent. Okay, if system of linear equations has no solution, then it is said to be inconsistent. Okay. Okay, now let's see how to solve the system of linear equations using determinants and matrices. See, let's consider three linear equations in the variables x, y, z. Okay, a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. Okay, here three linear equations of variables x, y, z. Okay, and constants d1, d2, d3. So here, and the coefficients of x, y, z, a1, b1, c1, a2, b2, c2, a3, b3, c3. Okay, now let matrix A is equal to a1, b1, c1, a2, b2, c2, a3, b3, c3. Okay, and let x is equal to column matrix x, y, z, and matrix B is equal to d1, d2, d3, matrix of constants. Okay, So listen carefully. Here matrix A is equal to, that is coefficients of x, y, z. Okay. A1, B1, C1, A2, B2, C2, A3, B3, C3. And x is equal to matrix, column matrix x, y, z. B is equal to column matrix, constants, okay, constant matrix D1, D2, D3. And next, see, here these equations can be written as, these equations, we can write this, we can express these equations, linear equations in the matrix form. See, x is equal to, sorry, not x, A1, B1, C1, A2, B2, C2, A3, B3, C3 into x, y, z, that is equal to D1, D2, D3. Got it? See here, see what we have done. This expression, that is these linear equations can be written in this form, that is in matrix form. See, if you expand this matrix, you will get the same thing, that is linear equations. See, you just multiply this matrix, multiply these two matrix and equate to this column matrix, you will get the linear equations, these linear equations. Okay. So what is this? This matrix is nothing but A, right? So it is nothing but x is equal to, it is B. So Ax is equal to B. So actually what we have to find? We have to find unknown x, y, z, right? That is x, y, z variables. We have to find the unknown variables x, y and z. Solving the linear equations means we have to find the unknown variables, right? That is x, y, z. So these things we have to find. That is nothing but matrix x. We have to find matrix x. See, for that, here we will multiply A inverse on both sides. Okay? Multiply A inverse on both sides. So it will be A inverse Ax is equal to A inverse B. Okay? Then. So A inverse, we can write it as A inverse A by properties of multiplication of matrices. So A inverse into A into X is equal to A inverse B. Okay. What is A inverse into A? A inverse into A is nothing but an identity matrix, right? So I into X is equal to A inverse B. I into any matrix is nothing but that matrix itself. Product of an identity matrix and the matrix, any matrix, that is equal to that matrix itself, that is original matrix. So here we can write X is equal to A inverse B. So what is X? The matrix X is nothing but X, Y, Z. Matrix, column matrix X, Y, Z. So if we find this one, see X, then we can write what are the values of X, Y and Z. So here X is equal to A inverse B. See, here we will solve the linear equation, system of linear equations using inverse of a matrix. Okay. So here to solve the linear equations, here we need to find the inverse of the matrix. Okay. So very important. Solve the linear equations. Okay, solving linear equations, at least one question you will be asked to find the solution, right? Find the solution of a given system of linear equations. So using this formula, this method, you just write this one. Okay, first of all you will write matrices A, X, B. Then here X is equal to A inverse B. So you have to find A inverse. Then A inverse into B, product of A inverse and B. So that time you will get a column matrix. Okay, a column matrix, and X is equal to, you will get a column matrix, equate. So X is equal to, Y is equal to, Z is equal to. Okay, so after go to example, you will understand it. Okay, now let's go through an example. Solve the system of linear equations. X plus 2y plus z is equal to 8, 2x plus y minus z is equal to 1, x minus y plus z is equal to 2. Say in 10th standard you have already learnt about solving the linear system of equations in three variables x, y, z, finding unknown values of x, y and z, right? That is using cancelling method, deletion method, right? So deleting method. So here it is completely different. Same thing, we have to find the values of x, y and z but using determinants and matrices. Okay. So for that, say it's very important. So and first see, remember this formula, x is equal to A inverse B. Okay. So here we have to write three matrices. First one is the coefficients of x, y, z. Okay, unknown variables x, y, z, coefficients of unknown variables. Then next matrix x is equal to, it is nothing but unknown variables, right? That is x, y and z. Next is matrix B, that is the column matrix of constants. Okay, now first of all let's write three matrices. A is equal to, here coefficients of x, y, z 1, 2, coefficient of z is 1, 2, 1, minus 1, 1, minus 1, 1. Okay. Next matrix x, that is nothing but column matrix of unknown variables x, y, z. And B is equal to column matrix of constants 8, 1, 2. Okay. Now we have three matrices. Next come to our formula. What we have to find? Here we have to find the unknown variables, right? Values of unknown variables x, y and z. That is the matrix x, right? So our formula x is equal to A inverse B. To find the matrix x, we need to find A inverse into B. So to find A inverse, here we have to find A inverse. To find A inverse, we need to find adjoint of A. Okay? To find adjoint of A, then we have to find minors and cofactors of all the elements of A. Okay, now here I am not going to find minors. Here I am going to write directly cofactors. Okay, write the cofactors directly. See, listen carefully. First one, A11. A11, cofactor of 1. Delete this row and column which contains this 1. So the determinant is 1 minus 1 minus 1 1. That is equal to 1 minus 1 minus 1, that is 0. Next is A12. See, when it comes to A12, here the sign is minus. Okay, so remember it is plus, it is minus. Okay, plus minus plus minus plus minus plus minus plus. Okay, so here A12, 1 to 1 plus 2 is 3, right? So minus 1 raised to 3, it is minus. So you see here it comes here, first one is plus, then minus, next plus, then minus. Okay, it goes in this way. So A12 is equal to minus of, here cofactor of 2. So remove this row and column. Okay, the determinant 2 minus 1 1 1, 2 minus 1 1 1. That is equal to minus of 2 minus minus 1, that is 3, so minus 3. Okay, minus 3. Then next A13. Here it is minus, so next is plus. Okay, then A13 means cofactor of this element 1. So remove this column and row, the remaining determinant 2 1 1 minus 1, that is equal to minus 2 minus 1, that is minus 3. Okay, next A21. A21 is equal to, here minus plus minus plus. Okay, next minus, here cofactor of 2. Delete this row and column, 2 1 minus 1 1. Okay, that is equal to 2 minus minus 1, that is plus 3 into minus, so minus 3. Next is A22. Here it is plus. Okay, determinant A22, cofactor of this one. Delete this row and column which contains this one, So remaining 1, 1, 1, 1. 1, 1, 1, 1. That is 0. Okay. Next, A, 2, 3. It is minus. Here, cofactor of minus 1. Delete this row and column. So 1, 2, 1, minus 1. Determinant 1, 2, 1, minus 1. That is minus 1, minus 2 is minus 3. Into this minus, so it will be plus 3. Next, A, 3, 1. A, 3, 1 plus, okay. It is cofactor of this 1. Remove this. So 2, 1, 1, minus 1. 2, 1, 1, minus 1. That is equal to minus 2, minus 1, minus 3. Next is A, 3, 2. Here it is minus. Okay. Minus of A, 3, 2 means this one, right? Cofactor of minus 1. Delete this row and column. So 1, 1, 2, minus 1. 1, 1, 2, minus 1. That is minus 1, minus 2, minus 3. Minus into minus plus. So plus 3. Next is A, 3, 3. A, 3, 3 is equal to, here it is plus, okay. A, 3, 3, cofactor of this 1. Remove this. So 1, 2, 2, 1. 1, 2, 2, 1. That is equal to 1 minus 4. 1 minus 4, that is minus 3. Okay. Now let's write cofactor matrix. Cofactor matrix is equal to matrix of A is equal to A11 0, A12 minus 3, A13 minus 3, A21 minus 3, A22 0, A23 3, A31 minus 3, A32 3, A33 minus 3. Okay, now let's write adjoint of A. Adjoint of A is nothing but transpose of a cofactor matrix. Next, let's write adjoint of A. Adj is equal to, that is transpose of cofactor matrix. So here interchanging the rows and columns. So first column will become first row, second column will become second row, third column will become third row. Okay. 0, minus 3, minus 3. Second column, minus 3, 0, 3, minus 3, 0, 3, minus 3, 3, minus 3, minus 3, 3, minus 3. Okay. It is the adjoint of A. Then, next here, see, to find A inverse, what is the A inverse formula? A inverse is equal to 1 divided by determinant A into adj, right? So here we need to find determinant of A. So let's find determinant of A is equal to determinant 1, 2, 1, 1, 2, 1, 2, 1, minus 1, 2, 1, minus 1, 1, minus 1, 1, 1, minus 1, 1. Not matrix, determinant. Okay. So that is equal to first element 1 into, remove this. So 1 minus 1. Okay, 1 minus 1 minus 1. So find the determinant here itself. Okay, 1 into 1. So minus 1, that will be 0. Minus 2 into, here delete this. Then 2 into 1, 2. Minus minus 1. So plus 3. Plus 1 into, remove this. So minus 2, minus 1, minus 3. That is equal to, here it is 0. Minus 6, minus 3. That is minus 9. Okay. Then we have got determinant A. Next we will find A inverse. What is A inverse? A inverse is nothing but 1 by determinant A into adj. That is minus 1 by 9. Okay. 1 by minus 9 or 1 minus 1 by 9. Determinant, this one. 0, minus 3, minus 3, minus 3, 0, 3, minus 3, 3, minus 3. Next we will find, what we have to find? We have to find the matrix X, right? So to find X, we need to multiply A inverse B, okay, by B. We have to find the product of A inverse and B. Okay, now let's find product of A inverse and B. So here that is equal to x is equal to A inverse B. Okay, that is equal to minus 1 by 9 into, it is A inverse into B. B is the column matrix of constants. Okay, now let's multiply these two matrices. Minus 1 by 9 into 0 into 8. See, there is only one column here. So 0 into 8, 0, minus 3, minus 6. Next, minus 24 plus 0 plus 6. Here minus 3 into 8, minus 24 plus 3 minus 6. That is equal to, see, we have got a column matrix. Minus 1 by 9 into minus 9. Here it is minus 18. Here 3 minus 6 is minus 3. That is minus 27, right? Minus 24. It is minus 21. Minus 6. Minus 27. Okay. Now, multiply these elements by minus 1 by 9. Scalar multiplication. Okay. That is here minus 9 by minus 9. Okay. Or minus 9 into minus 1 by 9. Okay. Minus 18 into minus 1 by 9. Minus 27 into minus 1 by 9. It is the scalar multiplication. We have to multiply all the elements by this constant, this scalar, right? So here minus 9 into minus 1 by 9, minus 18 into minus 1 by 9, minus 27 into minus 1 by 9. Here minus minus cancelled, so 9 cancelled, so it is 1, and it is minus cancelled, 9 2s are 18. Here minus cancelled, 9 3s are 27. See, here we have got x is equal to, okay, what is x? X is equal to, x is nothing but, that is matrix x, y, z. That is equal to matrix 1, 2, 1, 2, 3. Okay. We know that if two matrices are equal, then their corresponding elements are equal, right? So this implies x is equal to 1, y is equal to 2, and z is equal to 3. We got the solution. That is values of unknown variables. X is equal to 1, y is equal to 2, z is equal to 3. Very important, finding the solutions of given system of linear equations. So you should practice with many problems, many exercise problems, so that you will able to do the solve the problems very quickly. Okay, because you don't have enough time in exam, so you have to practice, because it's a long process. Means, see, we have to find the A inverse. Okay, to find the solutions of x, y, z, solutions of these equations, we need to find A inverse. To find A inverse, we need to find adj. So you should be careful about this finding cofactors. You see, if you do any mistakes in plus sign, so it will be the last answer will be wrong. So you should practice. Okay, so practice is must for. It is very important. Inverse of finding inverse, and here solving the system of equations. Next example, consider the matrix A is equal to matrix 2, 3, 4, 5. Show that A square minus 7A minus 2I is equal to 0. Hence, find A inverse. Solve this following system of equations using matrix method. 2x plus 3y is equal to 4, 4x plus 5y is equal to 6. It's very important question, 2014 question, okay, CBSE 2014 question. And see, first example which we have done is also 2015 question. So here we have to, first of all, we have to show a square minus 7a minus 2i is equal to 0. Okay, so let's find. So for that we need to find a square, right? So first a square, that is equal to 2, 3, 4, 5 into 2, 3, 4, 5. Okay, that is equal to, first row multiply with the first column, 2 into 2, 4 plus 12, 6 plus 15. Okay, second row multiply by first column, 4 into 2, 8 plus 5 into 4, 20. Next 4 into 3, 12 plus 25. That is equal to 16, 21, 28, 37. It is a square. Okay. Now let's find a square minus 7a minus 2i, that is equal to, we have to show it is 0. Okay. So a square is 16, 21, 28, 37 minus 7 into a. Multiply all the elements of a by 7. Okay. Scalar multiplication. 7 into 2, 14, 7 into 3, 21, 7 into 4, 28, 7 into 5, 35. Minus 2 into I. I is nothing but 1001. So 2002. Okay, 2 into I is 2002. That is equal to here. Let's first of all subtract these two matrices. Subtract the corresponding elements. 16 minus 14 is 2, and okay, directly we do 16 minus 14 is 2, 2 minus 2 is 0. 21 minus 21, 0, 0 minus 0, 0. 28 minus 28, 0, 0 minus 0, 0. 37 minus 35, 2, 2 minus 2 is 0. That is, we have got, it's a 0 matrix, that is 0. Okay. So we have got we have got a square minus 7a minus 2i is equal to 0. Okay. Next is, see, next one is hence find a inverse. See, here you have to find a inverse using this one. Okay, not by the method of finding a formula of a inverse. Okay, here you have to find a inverse using this one. Okay, so what is a inverse? See, for that we have to multiply a inverse on both sides. Okay, that is a inverse into a square minus a inverse into 7a minus a inverse into 2i is equal to a inverse into 0. That is 0. Okay. That implies here a inverse, here we can write a square as a into a, right? That is a inverse into a. So a inverse into a minus, here we can write a inverse into a, 7 into a inverse into a minus, here a inverse into I, a inverse 2 into a inverse into I, that is equal to 0. That implies here a inverse a is nothing but an identity matrix I into a minus, here it is 7i minus 2 into a inverse into I is a inverse itself. So 2 into a inverse is equal to 0. Then next is here I into a is a itself. So a minus 7i minus 2a inverse is equal to 0. What we have to find? We have to find a inverse, right? So let's take all other terms right side. Okay. So minus, take this one right side. Okay, no problem. 2a inverse is equal to a minus 7i, right? See, from this equation we can write 2a inverse is equal to a minus 7i. So a inverse is equal to a inverse is equal to 1 by 2 into a minus 7i. So here we need to find what is a minus 7i. Okay, now let's find 1 by 2 into a minus 7i, so that we will get a inverse. Okay, 1 by 2 into a is matrix this one. Okay, that is 2, 3, 4, 5 minus 7i, that is 7007. Okay, that is equal to 1 by 2 into 2 minus 7 minus 5, 3 minus 0, 3, 4 minus 0, 4, 5 minus 7 minus 2. Okay, So it is A inverse. Okay. So using this one, we have to solve the system of linear equations. Here system of linear equations of two variables, right? X and y. It is a little bit easier than that of three variables, right? So here 2x plus 3y is equal to 4. See what is our A? 2, 3, 4, 5, right? So write A is equal to 2, 3, 4, 5 and B is equal, X is equal to xy and B is equal to constants 4, 6. Okay. See here we have already got the value of matrix A inverse, right? So directly let's go to the formula, that is X is equal to A inverse B. Okay. So X is equal to A inverse B. XY is equal to A inverse into B. What is A inverse? 1 by 2 into minus 5, 3, 4 minus 2 into 4, 6. 4, 6. Okay. Now let's multiply this. So minus 5 into 4, minus 20 plus 18. 4 into 4, 16 plus minus 12. That is equal to, here 1 by 2 is here. Okay. 1 by 2 into. That is equal to 1 by 2 into column matrix. Here minus 2. Then here 4, right? Okay, 4. And now multiply these elements by 1 by 2. So we will get minus 2 by 2 is minus 1, 4 by 2 is 2. So we have got matrix xy is equal to matrix minus 1, 2. Equate the elements. So here we will get x is equal to minus 1, y is equal to 2. The values of unknown variables x and y. Minus x is equal to minus 1, y is equal to 2. Examine the consistency of the system of equations x plus 3y is equal to 5, 2x plus 6y is equal to 8. So here we have to check whether the system of linear equations is consistent or inconsistent. To check the consistency of the system of equations, see, first one, if determinant A not equal to 0, then the system of linear equations has one or more solutions. That is consistent. System of equations is consistent. Okay. And if determinant A not equal to 0, equal to 0, if determinant of A equal to 0 and edge A into B is equal to 0, okay, if determinant A is equal to 0 and edge A into B is equal to 0, then we say the system of equations is may or may not be consistent. Okay, remember determinant A is equal to 0 and edge A into B is equal to 0, then we say the system of equations may or may not be consistent. So here, if determinant A is equal to 0 and edge A into B not equal to 0, then the system of equations has no solution and it is inconsistent. Okay, so remember, if determinant A is equal to 0 and edge A into B not equal to 0, then the system of equations has no solution and it is inconsistent. So to check the consistency, we need to find determinant of A and edge A into B. Okay, now let's write matrix A, that is coefficients 1, 3, 2, 6. Okay, then find its determinant. A is equal to, okay, first of all let's write x, right? No need of writing x because here no need to find the values of x and y, right? So just write B. B is 5, 8. Okay. Then find determinant A, that is equal to 1, 3, 2, 6. That is equal to 6 minus 6, 0. See, here we have got determinant A is equal to 0. Next we will find the values of this one. Find the edge A into B. Okay, so to find edge A, we need to find all the cofactors of all the elements of A. So A 1 1, that is equal to, okay, directly we can write, right? It is a 2 by 2 matrix, right? So here we can write directly at J is equal to, that is, interchange the main diagonal elements 6 and change the sign of other elements, -3, -2, 1. Okay, so it is at J. Now let's find at J into B. What is at J into B? That is 6 -3 -2 1 into B is 5 8. Multiply these two matrices. First row multiply by first column, that is, there is only one column. 6 into 5 30 minus 24 minus 10 plus 8, that is equal to 30 minus 24, 6 here minus 2. Okay, it is not equal to 0. So here determinant A is equal to 0 and at J into B not equal to 0. Therefore, this system of linear equations has no solution and it is inconsistent. Okay, so this system of equations is inconsistent. So remember these three rules for checking the consistency of the given system of equations. So first one, if determinant A not equal to 0, then the system of equations is consistent. Okay, that is consistent, and to find the solution, x is equal to A inverse B. Okay, and determinant A is equal to 0. If determinant A is equal to 0 and at J into B that is also 0, then the system of equations may or may not be consistent. And if determinant A is equal to 0 and J into B not equal to 0, then system of equations is inconsistent, that is, it has no solution.